Today's video is sponsored by Forever Pick, exotic wood guitar picks. Handmade one at a time in Chicago, Illinois, you can choose from a selection of exotic woods that will actually improve your guitar's tone. Take advantage of an exclusive 25% off coupon when you buy the full 6-pack at the link in the description. And remember, when you support my sponsors, you support this channel, and I sure appreciate it. Hey, how's it going, guys? Brad the GUITOLOGIST here. You can see the fan is running in my living room here in this clip, and that's because my AC has gone out. It's 82 degrees in my house, and I need to figure out why that is. I think the dog may have something to do with it. He's chewed through some wires on the outside leading to my outside unit, so I'm going to have to go outside and check that and see what's going on. It's one of the hottest days of the year, and frankly, the audio on this isn't very good, so you'll have to bear with me here. Okay, so obviously the fan is working on the unit, but the compressor is not kicking on, and the dog has chewed through these wires in the past, and some of them are exposed. So I'm thinking that could be part of the problem. There's only 2 of those wires that are even hooked up, and I kind of taped them back to keep them from pulling them off any further. And he also kind of chewed off the insulation. It should be covered in insulation. This is the Freon. Okay, I'll spare you much more of that terrible audio right there, but I'm just pointing out that this is the line for the Freon, so this actually leads into the compressor, and I was just kind of unsure about the status of this because I was wondering whether or not he might have chewed through it somehow, you know, punctured it, and all the Freon leaked out. So right now I'm just kind of trying to ascertain whether it's that or whether it's something inside the panel here like a capacitor. So the first step I need to take is to trip this outside breaker to kill power to the unit, and then we can open it up. Yeah, you sleep it up, buddy. I'm pretty sure this is probably your fault. Okay, so what I'm doing here is just cutting off these zip ties that I put around all these wires and everything to kind of bundle them back up to keep the dog from chewing back through them. And I'm just going to check them because he did actually kind of chew through half of the insulation on some of these. And I just want to make sure that none of them are shorting out, you know, against anything. So, because if they're shorting out or grounding out, then it definitely would cause a problem. But these aren't the main power wires, though. These are the wires that run back to the thermostat. This has got to be one of the hottest days of the year. It's a fine time for it to happen. And that's usually when it does happen because, you know, it's going to fail when it's working hardest, obviously, especially if it's a capacitor. All right. Okay, so here's the panel. And this is the capacitor, and we should, let's see what we have here. There should be 2 different capacitors in this, one for the fan and one for the compressor. And if the compressor capacitor has failed, that'll be a problem. Discharge this thing. Make sure it's discharged before we start with it. It's old. I mean, you can see that because all the rust that's up here on the top of it. But we want to disconnect everything from it. And you can see I've worked on this before because this had come off, so I had to put a new connector on it, and it just let's see. Okay, so this conduit right here coming from the breaker, this is the main power conduit coming in here, and there should be 240 volts across that whenever it's on. There should be nothing right now. We'll just go ahead and check it for the hell of it. Yeah, there's nothing. Let's test this capacitor. That's really what I want to do. So we'll put it to capacitance right here. And this one, this should be the common, this. And this capacitor is measuring 48 microfarad, This one. This one's got nothing. Okay, so we could see here this capacitor is a 30 and a 5 microfarad. So there's two different capacitors in here, and they are at plus or minus 5%. And you can really tell that this thing is just beyond replacement time. So we're going to get a new capacitor in this, but just to satisfy myself, I wanted to put the probes on it one more time and double check it. There you go, 3.4 nanofarads on that one capacitor, and that's the one that's running the compressor. So that would explain most likely why the compressor is not kicking on. The other one is 4.8 microfarad. So actually it was close, and that's why the fan was still running, because there was enough to start up the fan on that one. Also, there's a nice little diagram inside of a lot of these units, and mine is no exception here. You can see the little diagram. So it shows you the wiring scheme for the whole thing. So if you kind of get lost, you can refer to that. And everything is color-coded as well. All of the wires are color-coded, so it tells you essentially how to just put one together. It's like paint by numbers. So it's kind of hard to screw one of these up. Okay, so it's time to go online and look for one of these. Again, I need a 30 and a 5 at plus or minus 5%. There are a lot of these on Amazon, and you could scroll down pages upon pages of stuff on Amazon, or you can go to Walmart.com or several other websites. Actually, at one point, I saw one on Lowe's.com, and I assumed that they would have those in stock, so I went into Lowe's physically, and the guy was like, "Oh yeah, we don't stock those." Well, why the hell don't you stock those? I mean, do you not do home repair, dude? Why would you not stock one of the most common failure parts in an AC unit? I don't understand that. And plus, it's a part that's fairly user serviceable as well. I think they don't want to encourage people to start getting into their HVAC systems, because it'll, obviously it's gonna screw up the monopoly that certain people have on fixing HVAC systems. But as a homeowner, this is the type of thing that you're going to have to do yourself from time to time. You're probably going to have to replace these. But I dug around in my drawer and I found a couple of capacitors that are used in guitar amps, and I was just curious to see if they were going to work while I waited for my parts to come in after I ordered them. So I installed what did I have here? I had a 30 microfarad capacitor, and the voltage is at, I believe, 500 volts. So I assumed, okay, 500 volts, 30 microfarad capacitor on the big capacitor. What could go wrong? So I was going to test it out and just see if it would run, my AC unit for a couple days while I waited for the other capacitor to come in. I know it's much smaller, but capacitors do come in a lot of different sizes. And I was just looking at the voltage. I wasn't really considering the amount of current that would be present in the system. Of course, the current is not going to go through the capacitor really from one end to end. So I don't know. I'm not sure why this did not work correctly, but obviously this thing failed. Whenever I throw the breaker, it just kind of explodes. I'm not sure if I caught this on camera or not. I'm kind of curious myself to see if I caught it on camera. But that little capacitor that's strapped onto the side of it, that's a 5 microfarad. And again, this is not meant to be a permanent solution. This is just something to get my AC working so that the house is not going to be, 90 degrees in the middle of the night while we're trying to sleep. So, and when it's late in the day and everybody's closed and you can't get the part locally, and you're having to rely on Amazon to deliver one either next day or 2 days later, you kind of get desperate. So, and in hindsight, I probably could have put some of these in series. A couple of those capacitors in series may have upped the value enough to be workable, like if I'd put 2 or 3 of those in series. But hindsight's 20/20. But you can see what I'm doing here. I'm just trying to rig up these smaller capacitors that I use in tube guitar amp applications, and I'll spoil it for you. They do not end up working. Actually kind of gave me a bit of a fright too, because you know, obviously I don't want to blow up my AC unit, so when I hear a loud pop, you know, I'm like, ah. Okay, so when this capacitor blew, it got me thinking maybe the compressor has a problem. Here you can see the compressor. You see that C, S, and R right there. Okay, the S, for example, goes to the yellow wire, which comes out here and goes right there to the HERM section of the capacitor. Then you also have the run right there, which goes to the red wire. In this case, it's more of an orange. And then you have the C, which is a black wire, which is the common. In order to check the compressor, we need to check the continuity between these windings that are in here. There's winding between the start and the common, and there's winding from the run to common also. So we're going to check from black to red, and then also from yellow to black. So if we do that, we'll check. We'll put it on ohms, and we'll check from black, which is our common. Start with the red. Okay. 1 ohm is actually normal, and I thought at first maybe that wasn't normal, but I kind of looked into it a little further, and yeah, that's about right for what I should see there. So if we go from black to yellow now, that's going to be measuring from common to start, and we have 3.24 ohms right there. Is that right? Yeah, we have 3.24 ohms there. Now if we go from red, over to yellow, that should give us the addition of both windings. So about 4 ohms is correct. So we had what, about 1 ohm at first, then we had like 3 ohms on the other winding. So what we're doing now is we're going through both of those when we measure from from the run to the start. We're going like this. We're going through this winding, and then from here, and then we're going through this other winding. So we're adding these together to 2 resistances. So the compressor looks to be okay. It's just something to do with this capacitor rating is just not rated for this application. Probably draws too much amps when it first starts up, and that might have something to do with how clogged the unit is. It could be low on Freon. It could be some other things too that are causing the amps to spike in the beginning. So we need to look into what that might be. We'll go ahead and take the water hose to this and clean these coils, because it's going to be off until tomorrow anyway, so might as well go ahead and do that. Okay, so the new part came in from Amazon. This is a Gentech capacitor, and I actually ordered the wrong one. It's a 35 and a 5 instead of a 30 and 5, but I did some research, and this one should be okay at least for a day or two until I get the actual correct one in. Kind of sucked because they listed this one. I did the search. They listed this one in amongst the search I did for the 30 and 5, which was kind of stupid. You know, you don't figure to have to double check that when you go down the list. So I bought the wrong thing, and oh well. Anyway, I did some research, and like I said, this should work. This one will actually make the compressor motor run with slightly less amps. If it was the other way around, I wouldn't even attempt it, because more amps, you know, would risk burning the thing up. But at least less amps, you're only risking like a little bit less efficiency possibly, or something like that. But lower amps is better than more amps. So we're going to go with this for now and use it for a day or two until the other one comes in. So let's see how it goes. All right, let's see how fast we can do this. I did pull some wires yesterday, so Alright, so brown is the fan. Okay, this one is a common. And purple is a common. These two have to go over here. This is called the contactor, I've found out. So I'm learning as I go here. Okay. Yellow is the HERM, which is the compressor. Okay. Like I said, this one is common. Purple is common. I'm going to double check this as well, but I'm pretty sure I'm correct on all this. Let's see. This one is HERM. Yellow is HERM. Brown is fan. Okay, let me double check it. Yellow is indeed HERM, and brown is indeed fan, and the other two, including the purple, is... The purple's also a fan, but it's the other side of the fan. It goes to common. Okay, this should be correct. Hopefully it doesn't explode. We do know at least that the compressor is good and continuous, so I think we're good to go. All right, 3, 2, 1. Nothing. Why nothing? Why nothing? Oh, because I have the air off inside. All right, 3, 2, 1. Okay, so I think that one will run for at least a couple days until I can get the other one in, so we're going to leave it at that. You like my helmet cam? Actually, I modified this out of a hat that was sent to me by Andrew at the Flatwoods Monster Museum. You can see his hat has been turned into my helmet cam. Ivy Sue, what are you doing?